Hello everyone. Today we are going to see about using contour integration. Show that 0 to 2 pi cos 2 theta divided by 5 plus 4 cos theta into d theta equal to, we have to prove that it is equal to pi by 6. So using contour integration. So for that we need to know about complex values. For z can be written as e power I theta. For e power I theta can be written as cos theta plus I sin theta. E power I theta can be written as cos theta plus I sin theta. In this, the real part of e power I theta, which means that is this is the real part, cos theta is the real part, and it contains the imaginary value. So sin theta is the imaginary part of e power I theta. Hope you all understand. That is, e power I theta can be written as cos theta plus I sin theta. It is the real part because it does not contain any imaginary value, and sin theta is the imaginary part because it contains the I as a imaginary value, and e power I theta is taken as z. So in our question we have cos 2 theta. So for that cos 2 theta, for cos theta can be written as real part of e power I theta. So if we have cos 2 theta means this is very easy. The real part of e power 2 I theta, which means that nothing but cos e power 2 I theta can be written as cos 2 theta plus I sin 2 theta. So that can be written as e power 2 I theta can be written as cos 2 theta plus I sin 2 theta. For that, real part of e power 2 I theta. So cos 2 theta can be written as real part of e power 2 I theta. So we consider that e power I theta is as a z. So we take on this as a z, means z power 2. So let me take this I equal to 0 to 2 pi cos 2 theta can be written as real part of z square divided by 5 plus 4, and cos theta can be written as 1 by 2 z plus 1 by z, and sin theta can be written as 1 by 2i z minus 1 by z. Now we have only a cos theta value, so we have to use, instead of cos theta, 1 by 2 z plus 1 by z. So we have to change it in the thetas or change it into z form. So for that, z equal to e power I theta, if we differentiate means dz equal to e power I will bring us a coefficient of before e power I theta. So I into e power I theta into d theta. So we know that we need to have, instead of d theta, we have to substitute the values of z. So it can be written as dz divided by I into e power I theta. If we leave d theta as here, means we take all the values as divided by. So for that, e power I theta can be written as z because we already consider z equal to e power I theta. So dz equal to iz equal to d theta. So instead of d theta, we have to replace dz divided by iz. So if we take, means what we get, so real part of this 1 by I is taken as common. Real part of 1 by I 0 to 2 pi, and z square as it is divided by 5 plus 2 and 4 are getting cancelled, that is 2 z square, because we are taking LCM, z square plus 1 divided by z, and dz by z because I is taken as the previous of before integral. So real part of 1 by I 0 to 2 pi z square divided by we taking LCM means 5z plus 2 into z square plus 1 divided by z. This z are getting cancelled because if we take in the normal form, means the z is taken in the numerator, so z and z are getting cancelled. So left out terms are written here. Real part of 1 by I 0 to 2 pi z square divided by, arranging the form of ax square plus bx plus c. So that means 2 z square plus 5z plus 2 equal to 2 dz. So we have to find the zeros of the value. So for that we need to use, because it is a quadratic form, we use a tree factor method here, means 2 2s are 4 and 5 is having down. So 4 1s are 4 and 4 plus 1 is 5. So our z1 and z2 values are z1 equal to z plus that means we having a instead of 1 we have 2, so 2z plus 4 and 2z plus 1 equal to 0, and our z equal to minus 4 by 2 and z equal to minus 1 by 2. For that, if we cancel means z1 equal to minus 2 and z2 equal to minus 1 by 2. So we have to take another form also. Either it is not a problem z1 is exactly equal to minus 2, no, z1 can be equal to minus 2 or minus 1 by 2, whatever the wish you can take, but in the form of residue only we have to be careful with this to find the residue. So I equal to real part of 1 by I 0 to 2 pi z square. This we have to need to know that if we have a coefficient of z square as some other values other than 1, we have to place that value in the next step, and instead of that we have to use z minus z1 and z minus z2 as in all the sums. It is the constant for all the sums. So our z1 can be find as modulus of z1. Our z1 is my z1 is 2 and z2 is equal to minus 1 by 2. So modulus of z1 equal to 4, and if we taking the square means we get z1 equal to 4 and z2 equal to 1 by 4. So comparatively z2 is lesser than z1. So that means z1 is lesser than z1 means z1 lies z2 lies inside and z1 lies outside. So for that, which the point lies inside the circle only we have to find the residue, or otherwise you can imagine if z1 equal to minus 1 by 2 and z2 equal to minus 2 means we get the values as z1 less than z2. So we have to find the residue of z1 because it is lies inside the circle. Now in my sum, the z2 is lies inside the circle, so I have to find the residue at z equal to z2. So whatever the point whatever the point lies outside the circle will be certainly equal to a 0, and whatever the points we inside the circle we have to find the residue. So to find the residue, limit z tends to z2, we have to choose if it is in the that form is lies in the question, we have to cancel it. So we have to take that, because 1 by if consider it is z2, so z2 minus z2 is 0, so it is we can't able to find the value. So for that purpose we are multiplying the term as it is z minus z2 f of z. This is the form. So limit z tends to z2, f of z is limit z tends to some value, f of z is a form. For why we are multiplying z minus z2 means we have to cancel it, because if we substitute the limit value as it is here means we get the value as 0. So for that we know we are using the z minus z2 values. For that limit z tends to z2, z minus z2, here the values as it is we have to place the values 2 into z minus z1, z minus z2. So this z minus z2 are getting cancelled, and if we substitute the limit means we get z2 square divided by 2 into z2 minus z1. So our z2 value is nothing but minus 1 by 2 and z1 value is minus 2. So z2 minus z1 is minus 1 by 2 plus 2. If we take a LCM means we get 3 by 2 as a value. So substitute here 3 by 2. Here previous value we have a 2. So 2 into 3 by 2 and z2 square is minus 1 by 2 the whole square. It can be written as 1 by 4 and 2 are getting cancelled. So it is 1 by 3. So the residue value at z equal to z2 is 1 by 2. We have to find the counter integration. For that, I equal to the what are the values here, real part of 1 by I. For this integration only we have to find the residue. So real part of 1 by I into 2 pi I, it is the constant for all the sum, into residue of whatever the residue which lies inside the circle, we have to multiply that. So for that, real part of 1 by I into 2 pi I is the constant into 1 by 12. So 2 I are getting cancelled and 2 divide means 1 2 are 2 and 6. So 1 here the balance terms are pi and 6. So our value is I equal to pi by 6. This is the answer we have to prove. That is, we have to prove that pi by 6 as answer. So we have proven. So hope you all understand, and thank you.